Hey there, this is lesson 18 and 19, drawing atoms. Really with atoms, what we care about now in this lesson are just the electrons, the E negative. Also making ions. What's an ion? I don't know yet, don't get ahead of me. It's the home edition because I have the cutest little 2-year-old sitting over there taking a nap because he's not feeling well, so I get to do this one on my couch with my cat next to me. Alright, so with these, if we're looking at the periodic table, the thing to remember is as you are going through these, you are adding left to right one more proton, one more electron. So every box is just one more, for all we care about now, is just one more electron. Okay, so if we're going to draw a picture of hydrogen, we start off by just putting the symbol in there, and a thing to remember is the period number equals the number of shells or rings that the electrons live on. Their energy levels, so the lowest energy would be toward the center. So hydrogen is on period 1, and it has 1 proton, so it has 1 electron. There's only 1 box that we fit so far. If I want to turn that into helium, I am still in shell number 1, period number 1, but now I have 1 box, 2 boxes to look at. In total, it has 2 electrons. Okay. On this, the best way to do notes is just write down the examples, add in, little notes on why they are the way they are. If we look at lithium, lithium is on period 2. So the first thing I would do is just draw on your 2 shells. Yay. Now, for these energy levels, the bottom one has to be full before the outer ones can be full. So if you know the second one only holds 1 box, 2 boxes, it only holds 2 electrons, it has to be full, so you can just fill it up. Then lithium has a total of 3 electrons, so if you put 1, 2, then the third must be on that shell. If we compare that to sodium, so sodium, third period, 1, 2, 3, pretend those are circles. You know the first 2 have to be full. So what is full for them? The first one only has 2 boxes as you build it across. So I'm just going to put numbers there. But it would have 2 electrons. The second one, if we count the boxes, it has 1, 2, 3, 4, 5, 6, 7, 8. So it has 8 electrons on it. And the third shell has 1 box. A total of 11 electrons is what we're looking for. So 2 plus 8 plus 1. So that's what that would look like if it, were nicer looking in circles. So you just count up, make sure that the total matches the proton number, so a total of 11. Also, make sure that the inner ones are full before you hit the outer ones. Now, if we compare these, sodium has 1 on its outer shell, lithium has 1 on its outer shell. When we add hydrogen, hydrogen had 1 on its outer shell. So all of these happen to have 1 on their outer shell. That is called the number of valence electrons. The inner ones are called the core. So the valence are the outer shell. So a really, really, really helpful thing for you to do is draw on your notes just a nice little table like this. And it's just a general, sketch. Something like that. I'll make it a little prettier. Try to put the correct number, put the correct number of columns in it. And we can label these. The number of valence electrons is just 1, 2. We ignore these right now. We'll worry about them later. 3, 4, 5, 6, 7, and 8. 8 is the magic number, except for in the first period. In the first period, it's just 2 is all we care about. So if we were going to draw something a little trickier, really it's not tricky, it's just with more stuff on it. If we're going to draw something with more stuff on it, let's draw a phosphorus. So phosphorus, right here, it's in shell, or period number 3, so it has 3 shells. 1, 2, 3. So number-wise, you know the first shell has to be full with 2, the second shell has to be full with 8, the last shell would have, like we just saw it, basically you count across and you skip these. So counting across, you count 1, 2, 3, 4, 5. It would have 5 in its outer shell. The most you can have in the outer shell is 8. If we're going to draw these with actual dots, I'll just do the outer shell. Doing this the right way is really helpful later when we bond these, because bonding is determined in some ways by how many lonely dots you have. So if you are just putting on 1, 2, 3, 4, 5 dots, like yes, you have the right number, you have 5 on the outside shell, but that doesn't help you figure out later on how many bonds it's going to make. So the way to do these on the outer shell is to go top, bottom, left, right before you pair any up. So it's 1, 2, 3, 4, and the 5th one you can put wherever. But top, bottom, left, right, and then you pair them up. Because we'll see later on the number of lonely dots. This guy, if you look a little bit closer, you would see this big, electron, but in the middle of that big electron is a frowny face, because that looks like an angry face. It wants a partner. It needs somebody else out here, but it doesn't have one. So the number of lonely dots is really helpful later. So top, bottom, left, right, then you pair them up. So if we looked at neon, this is where you could draw this, or pause it, draw it, see if you're right. So if we looked at neon over here, so now you can pause, see if you can draw it correctly. Neon is going to be 2 shells. First one has 2. The second one has 8. I'm going to draw it as 1, 2, 3, 4, and then you can pair them up. Now again, if you're really doing this just to get the answer, you know it's going to be 4 pairs, 2, 4, 6, 8. So you can do it whatever order. I do it that way when I'm showing it because that will help you later. So total of 10. Now, drawing these, after a while, we'll kind of ignore all the core electrons because the core ones don't really matter for reactions. All we care about are the outer ones. So if we have that same picture of neon, you could draw it as just the outer electrons, a picture like that. Or for our phosphorus, you could just draw like that. Okay, so why don't you draw, I don't know, show me what sulfur would look like. So pause it. I'm just going to unpause it. The answer will be up there for you. So yeah, do sulfur. Ready to go. Alright, so the answer for sulfur is it has 6 valence electrons, and top, bottom, left, right, and then pair up the other 2. So you should have 2 lonely dots. That means it needs to get 2 bonds somehow, 2 more electrons somehow. Which leads us to our next little section, is becoming an ion. An ion is an atom with a charge. Just write down, atom with a charge. It takes too long to write on this. Ion is an atom with a charge. It has a charge because it gains or loses electrons. So why would it gain or lose? So if we look at our sulfur that we just had, in order to get a full outer shell, it needs 2 more electrons. So somehow there's some other element somewhere that's able to give it an electron. And then another element that's able to give it an electron. So it has now a total of, let's see, sulfur would have at the beginning 16 protons, and it would have 16 electrons. So at a total charge, well, that would be a positive 16 and a negative 16. Total charge of sulfur is 0. But if it has a positive 16 and then a negative 18, because the original 16 plus, one electron makes it look like chlorine, another makes it look like the noble gas, argon. That's really what they want to look like, is a noble gas, because then that makes the atom more stable. If you total that up, that's a negative 2 charge. So what we had earlier of our 1, 2, 3, 4, 5, 6, 7, 8, our valence electrons, what you have is kind of this split down the middle, where on one side, these are going to lose electrons. The other side, they're going to gain. If you lose electrons, you become positive. These, if they gain electrons, they will become negative. So you're looking at positive ions, an atom with a charge, and negative ions. The name of a positive ion is called a cation. If you need to remember how to remember that, it's that cats are always positive because they hang in there, like the poster with cat on branch. A cation. An anion is negative because an or a is kind of a negative prefix. So that's the name for those. So if I have one extra electron, I want to get rid of it, that makes me have a positive 1 charge. If I have 2 extra electrons and I want to get rid of them, that gives me a 2 positive charge. A 3 positive charge is what I get if I get rid of 3. So that would look like aluminum, for example, has 3 valence electrons. It's going to find some way to give those up. So it's going to find something that wants 3 of those, or 3 things that each want 1 of those, or some way to get rid of those in order to make itself happy. If you have 5 valence electrons, is it easier to give up 5 or to gain 3? All these things are the smallest number, basically. So it's going to be easier for it to give up 3, or to gain 3 than to give up 5. So it's going to be moving this way, 1, 2, 3 spots. So that would have a 3 negative. If you have 6, if you want 8, you need to get 2 more. So it's a 2 negative. If you have 7, you want to get 1 more, so that's 1 negative. And things with 8 are already good. Noble gases don't have to react. So phosphorus lives right here, one of these. So phosphorus had 3 lonely dots. That means it wants something to give it 3 electrons. So something will send it 1 electron, another electron, another electron. So phosphorus will now have a 3 negative charge because it has 3 extra electrons. Our aluminum earlier, you'd write it like 3 positive. So if phosphorus wants 3 and aluminum can give away 3, the way this works is, on your fingers works really well. Phosphorus wants 3. Aluminum can give it 3. So you pair those up. And everything's fine. There aren't any leftover lonely electrons hanging out. So all of them get paired up. And that's kind of the next part that we'll look at too. So that's a little preview of that. Yeah, I think that's all I wanted to tell you.